Amir invited me to talk about connectivity today, to talk about 50 years of my life's work in 16 minutes. And we're down to 15 and change now. In the next 16 minutes, I want to convince you of the following fact. The most important new fact about the human condition is that we are now suddenly connected. And I'll come back to that a little later. You all know the Chinese expression, don't you? If you want to get rich, first you build a road. So that is connectivity wisdom, a road being an early form of connectivity. The Romans then stole it from the Chinese, and this is a subway map of the Roman Empire. And as you may remember, all roads lead to Rome. And then came the Industrial Revolution, and a guy named Metcalfe built the first 180 miles of road kicking off the Industrial Revolution. And even after his great accomplishment, they still spell his name wrong. But then in 1946, this is a picture of me, 1946, holding a telephone. I was very lucky to be born in 46 because of what happened in 47, which I've listed here. A bunch of other things happened, but the wireless television kicked off. You remember those that had rabbit ears? No, you're too young, you don't remember them. That began in 47. Microwave oven, first life to space and back, the CRT video game. But most importantly, in 1947, was invented the transistor. And that small switching device then led to a shift. Connectivity then shifted. We went 2 bits, networks, internet, from roads moving atoms. And this became, 20 years later, in 1969, the first 4 nodes of the internet. Santa Barbara, SRI, UCLA, and Utah. And the first internet message was sent on October 29th, 1969. And they were going to try to log in from UCLA to SRI, and Charlie Klein typed L for login. And then he typed O, and then it crashed. And his claim was this was God saying, lo and behold, the internet. But because I had been a student at MIT studying digital electronics, I got the job of building this device for connecting MIT's computer, it's PDP-10, to the internet. So this was my entree into the movement of bits through the internet. So by 1973, this is what the internet looked like. And those 2 yellow splotches were where I put MIT on the internet, and then I put Xerox Research on the internet. But that's the whole internet right there. And an interesting fact is that these are the transcontinental trunks of the internet in 1973, carrying all the worldwide traffic of the internet. And these circuits ran at 50 kilobits per second. I know you don't use the prefix kilo anymore, but let's refer to this in preparation for later. We'll refer to this as the kilobit internet. And the other thing to observe about this is that most of these machines were time-sharing machines with dumb terminals, and your access to the internet was through a character mode dumb terminal. So this is another picture of me, I just couldn't resist, of a grad student at Xerox Research, having put MIT and Xerox on the internet. I was then sitting in my office wondering what to do next. And Xerox, let me tell you what was going on in my office that day. You see that device? Texas Instruments Silent 700, top of the line computer terminal, 30 characters per second. And had a cable out the back, an RS-232 cable, that ran at what we used to call 300 baud, or 300 bits per second. And then up there is a box of 35 millimeter slides. So I was on the board of the company that developed PowerPoint. We sold it to Microsoft in 1987 for $14 million. This is 1972. That's how we did presentations in those days. We made 35 millimeter slides with a camera and put them in a projector. Let's see, over here, this is a Rolodex, an actual Rolodex. This you may recognize as a telephone right there. These are pencils. And this, although it didn't make it into this photograph, is the IBM Selectric typewriter upon which I typed the memo inventing Ethernet. And the reason I got to invent Ethernet is because the Xerox Research Center decided to develop what was called personal computers. And the idea was that we would put one on every desk. Here's a bitmap display, very advanced, a mouse. These are 2 megabyte removable disk drives, megabyte. We call these pizzas, and you put them in the pizza oven here. And the way you printed was you would take a file and put it on one of these disks and carry it over to the printer, which also had a pizza oven, and put it in there, and then you would print. But instead, we decided that we wanted to put all of these on a network. And who was the networking guy? Me. I lucked out. And so Ethernet you can't see, but Ethernet is on the back of this machine, running at 2.94 megabits per second. Now, in designing Ethernet, right away there were 2 architectural connectivity architecture principles. One was packet switching. The fundamental technology of the internet is switching packets of data with a destination address and a source address and some number of bits with codings in them. And so Ethernet had to carry packets. And more generally, I only had to worry about the lower levels. We had this beautiful architecture for connectivity architecture for the internet, where we took all the functions of networking and divided them into 7 layers. And Ethernet only had to provide the physical means and the low-level data link, and higher-level protocols would take care of everything else. And this was a great tool because it allowed Ethernet to be very simple, fast and simple, because it only had to do these things. It didn't have to do all of this too. So we've talked now about 2 architectural principles related to connectivity, namely packet switching and the 7 levels of the ISO reference model. So then we invented Ethernet. 1973, May 22nd, the memo got typed on the IBM Selectric, and it used Manchester encoding to send the packets down a thick coaxial cable at 2.4 megabits per second. And the beauty of Manchester is there was no central clock. Each packet carried its own clock and clocked itself into its destination memory. We then used a Gerald vampire tap. We wanted the network to share a cable, a big, thick, half-inch yellow cable, but we didn't want to have to take the network down every time we inserted a new PC, so we adopted the Gerald tap, which punctured the insulation and attached the PC to the network without bringing the network down. And finally, we needed a way for the machines to take turns sending their packets through this cable, and we adopted from the Aloha Packet Radio Network at the University of Hawaii. I spent a month there studying this. We adopted AlohaNet randomized retransmissions. So these are sort of the 3 technological decisions that led to the first Ethernet, but none of those 3 endures today. None of them is very important. Here are the 3 important things that happened. First of all, as I mentioned earlier, prior to Ethernet, people used dumb character mode terminals to access the internet. And Ethernet extended the packets all the way to the desktop. So you would no longer have character mode, it was packet mode all the way. We then moved from, this is the 300 bits per second from my silent 700 dumb terminal. Suddenly, the next day, I had 2.94 megabits per second coming in and out of my office. That is a speed up of 10%, 100%, double, triple, 10 times, 100 times, 1,000 times. No, that's a speed up of, as you see written here, 10,000 times. So at this point, bandwidth became abundant, and this was the breakthrough that enabled cat pictures on the internet. And finally, Ethernet became part of a movement. This is the standards movement. TCP/IP was an open standard for connecting machines together, and Ethernet joined that family, all of which were developed beginning in 1973. And then, of course, you'll recognize in 1989, 3 more standards joined: HTML, HTTP, and URL. So now we had to sell Ethernet outside of Xerox, and I started a company called 3Com that sold, among other things, Ethernet. And most people didn't have PCs, which was awkward, since the purpose of Ethernet was to network PCs. So we made a 3-node starter kit, and with this starter kit, you would have 3 PCs and a piece of cable running between them, among them, and then you'd have a software that allow you to share a disk. If you put a disk on one of the machines, you could share it with the other 2, or you could take a printer and share it with the other 2, or if you had an email to send, you could send email to anyone you wanted on the other 2 machines. And this worked. Our customers confirmed that this worked, but it was not useful, which is damaging to a startup when its customers are not happy with their products. So I made this slide up, which basically said that the cost of the network goes up linearly. It's about, at the time, it was about $750 per PC. But the number of possible connections, which I took to be the value of the network, grew as the square of the number, so that there was this critical mass point where the values exceeded the costs. And so my 6-person sales force went out with this 35mm slide and convinced people that the only remedy to this problem was to buy more of our product. That is, if the networks got bigger, they would be more valuable, and eventually very valuable, as it turned out. That slide became Metcalfes Law. It was called that in 1995, and I've been defending it ever since. And one day I ran into Gordon Moore. You may remember, Gordon has a law too. Have you heard of that law? So here's Gordon saying, well, Bob, I've noticed both our laws begin with M, but mine's been numerically true since 1965. What about yours? So that was an early defense. These are 2 connectivity laws. And then there was a third. Martin Cooper invented the cellular telephone and made the first call once again in the year 1973, the year Ethernet and TCP/IP came along. And Cooper was building, of course, standing on the shoulders of Marconi, who got a Nobel Prize for inventing radio. And he won the Nobel Prize by having the radio go further and further and further. But all progress since Marconi has been having the telephone go shorter and shorter and shorter distances. And so that the number of conversations per square kilometer has been going steadily up ever since, according to Martin Cooper's law. So there you've seen 3 laws about connectivity. So this year we're celebrating the 50th birthday of the internet. There have been celebrations across the US. You know, success has many fathers. So everybody's throwing a party and claiming a little bit of credit for having invented the internet. Well, of course, it was me all the time. And here's this fact, this most important new fact about the human condition, which is that we are now suddenly connected. So here's a plot of the number of connections of the internet since 1969. So 50 years later, the World Wide Web is 30 years old. Now 4.39 billion people are connected on the internet. And by the way, that's not going slowly. That's up 9% year to year. So that's 57% of us humans, 7.7 billion of us, are on the internet. And by the way, on the internet, we are already outnumbered by the things. There are 8 billion things with us humans. But look at this chart. Now, this is a chart that shows you poverty. So here is extreme poverty, slowly growing as population is growing. This is the internet. This is the World Wide Web, and shortly after the World Wide Web, worldwide extreme poverty starts going down. So this is one of many arguments one could make that connectivity is a good thing. The more connectivity, now this, I understand the difference between correlation and causality. There's always somebody who likes to point that out. Anyway, correlation is a hint about causality. Anyway, I claim that all this connectivity is leading to freedom and prosperity. Okay, so here are some of the famous disruptions of connectivity. U.S. mail, journalism has yet to recover, telecom. You remember there used to be 3 industries, voice, video, and data, and we went to endless conferences about the convergence of voice, video, and data. It happened. Transportation. Then there's the big ones, I think, that are coming up. Education, goodbye bricks and mortar education. Energy through distributed energy generation. Healthcare, personal, preventive, and perpetual. Actually, this conference will be disrupted. At some point, we're going to stop coming physically, lugging our atoms to this conference. So we will attend it by just sending our bits there. That'll be a disruption of the conference business. And then there are the pathologies. I mentioned the connectivity was sudden. It's the suddenness that has caused these pathologies, I call them. For example, porn was one of the first. They were going to shut the internet down because its first use was to carry porn, but of course that's all been eliminated now. And advertising was once decried as an abuse and misuse of the internet. Haha, there was the monetization secret right there. Of course, then there's the polarization, and excuse me, this is a boomer referring to millennials as a pathology. And then there's hate speech, and of course, fake news is also a pathology of the suddenness. So we are now learning how to handle news. And at the moment, we haven't figured it out. So we have this thing called fake news. I do know that we made a mistake by asking Facebook and Google and Twitter to filter fake news. We made a mistake asking them to do that, and they made a mistake by agreeing to try. And so we're going to figure that out in the coming years. And so you could argue, one would ask, are we halfway there now? Half the people on Earth are on the internet. Are we halfway there? We only have to wait another 50 years and everyone will be on the internet. And I claim not, because speed and reach are not the only dimensions of networking. And you saw that point made. Elise Neal from Verizon made this point beautifully yesterday about 5G. 5G isn't just fast, and it isn't just low latency. She had 5 or 6 other characteristics, which I have a different but similar list here. We have many dimensions of connectivity to explore before we're done. And this leads me to the closing thought. I've called it temporarily the node network paradox. We talked about transistors invented in '47, and we haven't, in this conference, we've been talking about neurons, the structure, the nodes of the brain. And if you look at these, the transistor is about billions of times faster than the neuron. It's millions of times smaller than the neuron. But in a head-to-head contest, the brain, 20 watts, about this big, can outcompute a gazillion transistors. So why is that? Why is this grossly superior node outperformed by this pitiful biological node? And the answer is, what is the answer? Connectivity. The brain has figured out connectivity much better than we have, so there's lots of headroom. I think of the brain not so much as a model for future connectivity as an existence proof. We can do a lot better than we're currently doing with transistors. So we are now suddenly connected. We haven't finished digesting the last round of connectivity from the megabit internet. But guess what? Here it comes. It's already here. You heard about it yesterday, 5G, et cetera. What I'm calling the augmented video mobile gigabit Internet of Things is coming, ready or not. Thank you.